EHS aspect, the next thing is to evaluate the EHS aspect. Now, we have another form, an ISO form to do this. Now, if you're going to scrutinize this form, you would see that the first half of the form, the second form, is actually a summary of the EHS aspect identification form, wherein, again, you have the different items, the different EHS aspects that you have identified per process, and then determining the control, whether it's direct or indirect, and then what particular activity area or equipment are you getting this aspect from, and then what are the impact of each of these aspects, and then what condition for this to occur or to happen, and then what existing control do you have. So again, this is just a summary of what you have just done in EHS aspect identification. But what's significant about this second form is the evaluation itself, wherein you're going to identify the regulation, the regulatory laws, or the regulations and laws that would address each of these EHS aspects, such as RA 8749, RA 9275, RA 9003, as well as RA 6969. Now, you have to determine whether the company is compliant or non-compliant with these regulations. And then, the last part, which is the most significant part of this second form, would be the risk assessment. Now, going back to the definition of what is a risk, it's actually the product of occurrence, the probability, as well as the severity of this risk to occur. Now, in this form, what you're going to do is you're going to involve a numerical value so that after multiplying these three parameters, you're going to have a rating, a specific rating. And then this rating will be compared to the ISO standard rating. And then you have to conclude if it is higher than the ISO standard rating, that means you have to do something about the process to minimize the risk. So how would you evaluate or give a numeric value for the three parameters? You have to have your own rubric. Okay. So the next slide shows you the different ratings for the probability, the detection, as well as the seriousness of a particular risk. Now, who would be the source of this rubric? There's no one that can be a best source of this rubric than the process owner. Process owner would be you if you happen to be a process engineer, because you know already the in and out of the process, as well as in the first step, you have identified already the different aspects using life cycle assessment. So, based from this example of the rubric, you have here the rating, the numerical rating 5 as the highest and 1 as the lowest. In terms of, as mentioned, detection, probability, as well as seriousness. But in some practices in industries, they have divided the seriousness in terms of environmental, health, and safety concerns, plus the business concern. Because in ISO, they have what you call BCP, or Business Continuity Program. Why? Because they have identified that most of these impacts that are caused by the EHS aspects can brought about haltering or stopping of this process. And of course, based from the principle of sustainable development, it would affect the profitability of the company. And thus, the seriousness would involve not only the EHS concern, but also the business concern. The three parameters that are involved in calculating risk in the form that we have discussed are occurrence, control, and severity. But in ISO, they have utilized another terms for these other terms for this OCS, occurrence, control, and severity. That is probability, detection, and seriousness. At any rate, whatever is the product of OCS, occurrence, control, and severity, would be considered also as the risk if you use probability detection and seriousness. So if you're going to multiply, looking at the form, if you multiply the occurrence, control, and severity, which is also equivalent to probability detection and seriousness, and you have found out that the product of each aspect would be equivalent to the RAR, or even greater than the RAR. What's RAR? This is risk acceptable rating. Based from ISO, the RAR equivalent or value should be 12. So if the EHS aspect that you have identified would be corresponding to a RAR greater than 12, that means you have to go back to the procedure. Because remember, the EHS identification will be based from the procedure that the company has established. But if it is lower than 12, of course, since ISO is part of CQI, remember, CQI is continuous quality improvement, you can even make it low, the RAR, or the risk acceptable rating. So that's our objective as environmental engineers. Now, after doing this inside the industrial plant, there are also some environmental scientists, environmental planners, and environmental managers that are still concerned about the risk outside the plant. So the next steps that I will be discussing to you would be based from the kind of era that is being done after EIA. You remember in the introduction. So what are the steps in risk characterization or in ERA? One is hazard assessment, followed by dose response assessment. Then you have to characterize the risk based from the exposure assessment. Take note that the hazard assessment and dose response assessment can be done parallel with exposure assessment, so as to characterize after the risk. In hazard assessment, this table of hazard categories and examples of potential hazard manifestations can be utilized in identifying the hazard. There are 4 basic classification of hazards. We have human toxicity hazards, which includes carcinogenity, mutagenity, and any impact on humans. Another classification of hazard, or another category, is environmental toxicity hazard, which includes aquatic toxicity, avian toxicity, amphibian toxicity, phytotoxicity, or mammalian toxicity. The third category of hazard are physical hazards, or is physical hazard, which includes explosivity, corrosivity, oxidizers, reducers, the pH of the substance, as well as its reaction with water. And lastly, the hazard category is called global hazards. So these global hazards will refer to those environmental impacts that you have learned, such as acid rain, global warming, ozone depletion, and so on. Now, another diagram would help you to identify whether the human hazard is serious or not. So you have here a diagram that shows that if you just have a skin rash, cough, throat irritation, headache, or dizziness, this will fall under less serious. And normally, if it is less serious, it is reversible, not debilitating, and not life-threatening. On the other hand, you have more serious, irreversible processes, debilitating and life-threatening, when the substance would affect or would cause kidney and liver damage, can cause cancer, can damage the nervous system, or even can cause birth defects and miscarriages. So you have to determine whether the impact on health would be less serious or more serious. This can help you predict the value of the risk. Now, since we cannot do it by quantity, there is an estimation technique that is being used to estimate the risk. Now, if you're familiar with the terms such as LC50 and LD50, your LC50 means lethal concentration at 50 population. What does it mean? They process wherein they get a certain concentration or different concentrations of a particular substance to determine its LC50. What is LC50? Let's say they use rodents to be injected with the particular chemical. Let's say the population of the rodents, why rodents by the way? Because rodents are found to have the same physical chemical characteristics as humans, and they react to different chemicals just like humans do. So rodents or mice or rats are actually the commonly used testing animals. Now, what does LC50 mean? Let's say the population is 100. They would test at what concentration would half of the population would die. That's why it's called lethal concentration. On the other hand, if it is LD50, this time what will they do would be they will have variations of dosage of these chemicals, and then again they will find out at what dose would half of the population would die. So after identifying that, they will plot it in a curve, and then plotting it in a curve, they have to identify the threshold. So look at the figure. So here they have the reference dose, and then they plot the dose response curve. The last point or the zero probability from the curve would indicate the threshold limit. And normally, they assign a dose or a concentration that is lesser than the threshold, and this dose or concentration is what they call NOAEL. What is NOAEL? No observable adverse effect level. So this is how they do it. So they conduct the experiment, they plot the dose response curve, they identify the minimum dose or the minimum concentration, and then from the minimum concentration they get a lesser dosage or a lesser concentration as the threshold, as the NOAEL, in which it would serve as their limit, the no observable adverse effect level.